Hi there, in this video clip today I want to talk about the reactivity of metals. In the past I've spoken about group 1 and group 2 and group 3 metals. Group 1 metals are more reactive than group 2 metals, which are more reactive than group 3 metals. There's a series, a table of reactivities called the electrochemical series or the reactivity series. It's simply a list of metals arranged according to their reactivity. The reactivity is based on the reactivity of the metal with two things or three things, such as oxygen, water and acids. Let's look at them. How do you remember? Well, there's a mnemonic, a memory aid, and it goes a bit like this. Please send lions, monkeys, cats, and cute lions, zebras into lovely hot countries signed General, and I'm running out of board, General Penguin. We use this mnemonic to remember the reactivity series of metals. What are they then? P, potassium, S, sodium, L, lithium, M, magnesium, Ca, calcium, aluminium, carbon, zinc, iron, Fe, lead, Pb, H, hydrogen, C, copper, S, silver, Ag, Au is gold, and P is platinum. It's a reactivity series remembered by, like I've just said, you can remember it by the mnemonic. Please send lions, monkeys, cats and cute zebras into lovely hot countries signed General Penguin. This series, at the top, the most reactive, so going up is more reactive, and would you believe this, going down is less reactive. Let me show you an example of this. If I took the reactivity of these, let's have a colour change. Let's try green. No, yes. The reaction of these with water, H2O, or with acid. If I add potassium to water, it bursts into flame. If I add potassium to acid, it explodes. And if I got further down here to the copper, down here copper, silver, gold, platinum. There's no reaction at all of those, none. They don't react with water or with the acid, they're very unreactive. Going down here, by the time I get around that position, these react slightly, they are slow, and exactly the same by the time I get around this area. The reaction with acids is slow and above very reactive. So, and the same would apply to oxygen. So the reactivity series is built upon the relative reactivities of the metals with oxygen, I haven't done that yet, and with water and with acid. These can be made to react with steam to quicken them up, but that shows you, I mean, if you add, like I've already said, you add potassium, a lump of it, into acid, boom, it explodes. So it's a way, this electrochemical series, a reactivity series, remember it by the new moniker. Now, I just want to look a little bit more about this. If I drew a line across there with carbon, for example, carbon's there, how do you extract these? I've put that in as a reference point. They can be extracted by electrolysis, and below carbon they're extracted by reduction, and we generally use carbon, heat them up with carbon. Now, I've mentioned in the past, group 1, they easily form ions plus 1 ions. Group 2 elements, calcium, magnesium, they form C2 plus ions, and aluminium, found in group 3, forms Al3 plus ions. So let's look at a little example. Suppose I said I'm going to take magnesium sulfate, MgSO4, and I'm going to take Mg, and I react it with copper sulfate. What I get is I get MgSO4 plus copper. Notice this, that what's happened is the magnesium, here it is, has displaced the copper, which is right down there, because it's more reactive and it's found higher in the electrochemical series. Let's look at this equation in a bit more detail. Mg, the metal, hasn't got no charge on it. Magnesium has got a charge of 2 plus. Copper has got a charge of 2 plus, and copper, the metal by itself, has got no charge in it. So the Mg is going from Mg0, if you like, no charge, to Mg2 plus, and the copper is going from Cu2 plus to Cu0. This has, can you see that? That has lost electrons, and this has gained electrons. And there's a second mnemonic mnemonic I'm going to put up there now. It is oil rig. Oil rig, OILRIG, and that stands for oxidation is the loss of electrons, and the opposite of oxidation is reduction, is the gain of electrons. And if you look at that table going up there, this is very reactive. It's easily oxidized because oxidation is the loss of electrons, and as I get further and further down they become less reactive, and that is why it's easy to oxidize group 1 metals, group 2 compared to some of these metals down here. And that is the concept of oxidation and reduction. Let's take an extraction, right? Fe2O3. That is called hematite. It's an iron ore. And on that position, I've said anything below carbon can be reduced. There he is. So how do you extract iron from its ore, hematite? The answer is by reduction, because if I complete that equation now and I heat it with carbon, it goes from just trying to remind myself, it goes to 4Fe plus 3CO2. Let's look at that. Here, Fe going to Fe, and this is the reduction of iron ore hematite. That is Fe3 plus, going from Fe3 plus to Fe, I'm going to put a 0 because metals are neutral, and that is reduction, i.e. plus 3 electrons. The gain of electrons is called reduction. And that's all I want to say about the electrochemical series. I've mentioned the mnemonic 1, mnemonic 2, oil rig. Oxidation is the loss of electrons. Reduction is the addition of electrons, and it could be said in another way. Oxidation, would you believe this, can be defined as the addition of oxygen. Reduction could be said to be the addition of hydrogen, but I'll talk about that in greater length soon.